Okay, so this one we have bracket -1 to infinity. So since it goes to infinity, positive infinity, I know that it's going to be greater than. Now since it has a bracket on this -1, it's going to be greater than or equal to -1. And then we draw our graph. And since it can be equal to -1, and then it goes to positive infinity. Now on these, I didn't really mean to remember to work these out, but they're just moving, you know, like when we solve an equation. So they subtracted 10 here. So x subtract 10 is still less than 0. There's only one time when our sign is actually going to change, and that would be if we divided or multiplied by a negative number. So this one, they just divided both sides by 4, and it wasn't a negative, so x is still greater than 5. There's one down here where I'll show you it's going to change. So first thing we'd have to do on this one is solve it for x. So we'd subtract 8, so I'll have x plus 8. So you'd subtract 8 and have x is less than 3. 8 times 10, 11. So this is our inequality. Our notation is going to be negative infinity, since we went less than, 2, 3. And our graph will be at 3 and going down the number line, just like this arrow. Right here, I have 1 subtract 3x is less than or equal to -2. So 1 subtract 3x is less than or equal to -2. So the first thing I'm going to do is move this 1. So I'd subtract 1. So I have -3x is less than or equal to -3. Now this is -3x, so I'm going to have to divide by a negative. When I divide by a negative, this sign changes. So I have x is greater than or equal to -3 divided by -3 is +1. So whenever there's a subtract or negative x, however they put it, our sign is always going to flip. So our inequality is going to be x is greater than or equal to 1. Our notation, since it's equal to, we'd have 1 to positive infinity, and our graph is going to be 0, 1, 2, and it can be equal to 1, so bracket up the number line. On these, we're going to treat them like linear equations and solve them. And we just have to keep in mind that if there is a negative, we're going to have to change that sign. So since this is subtract 3, add 3. So I move my 3 to this side. This is positive 5x. I'm going to subtract 5x. But I did not divide or multiply by a negative, so I don't have to change that sign. 7x subtract 5x is 2x. Is less than or equal to 5 plus 3 is 8. Dividing by 2 is +2. So x is less than or equal to 4. That would be my inequality. My notation would be negative infinity to 4 with a bracket. On this one, if you notice there's 2 signs. Whatever I do in the center to solve for x here, I'm going to have to do here and here as well. So since it subtracts 6, I'd add 6 here, here, and here. So I'd have 6 is less than or equal to 2x, which is less than or equal to 12. And then I divide by 2. And it's a +2, so I don't have to worry about changing the signs. So 3 is less than or equal to x, which is less than or equal to 6. And then my interval notation would be 3, 6. Last one, this is 5, and it'd be 5x subtract 4 divided by 5, so we'd multiply. by 5, so that this would cancel. Negative 2 times 5 would be negative 10, is less than 5x subtract 4, which is less than 5 times 0 is 0. Add 4. Negative 10 plus 4 would be negative 6, is less than 5x, which is less than 4. Divide by 5. Have negative 6 over 5 is less than x, which is less than 4/5. When we write this in integral notation, we're going to use parentheses because it's not equal to, bigger parenthesis, comma, 4/5. And that would be inequalities.